So, our topic for today is all about elementary applications of differential equations. First order, specifically, our topic is all about orthogonal trajectories. So, suppose that we have a family of curves given by function of x comma y comma z is equals to 0, and then one curve corresponding to each c in some range of values of the parameter c in a certain application. It is found desirable to know that what curves have the property of intersecting a curve of the family at right angles whenever do they intersect. So suppose in our previous topics, um, so far we have solved differential equations of only one form, which is this one, m dx plus n dy is equal to 0. Then, for such an equation, so solving for dy over dx, we will have dy over dx is equivalent to negative m over n. So, the differential equation of the orthogonal trajectories is given that dy over dx is equivalent to negative 1 all over m all over n. So this will become the orthogonal trajectories. Ortho orthogonal gonal trajectories of the given curve. Trajectories. Uh, trajectories. So this will become n all over m. So or we can say that this one this one is also equivalent to this n dx minus m dy is equal to 0. So to see this, let's try example. By the way, these are the steps in solving our uh, orthogonal trajectories. First is that eliminate the the arbitrary constant by differentiating the given equation by differentiating the given equation. Next, after doing that, after differentiating and eliminating the arbitrary constant, the next step should be change dy change dy over dx into negative dx over dy. Then, after that, the third step is integrate it with respect to its variable and add arbitrary uh arbitrary constant c. So to see this, we should try example number 1. We are given that one in example number 1, that y is equals to c all over x. First, we should eliminate. According to our procedure, we should first eliminate the arbitrary constant by differentiating the given equation. So first is I will cross multiply this one. So we will have x multiplied by y is equals to c. Now we can eliminate our arbitrary constant. So differentiating both sides of the equation, I'll just change my color. So differentiating both sides of the equation with respect to x. So we will have uh, product rule. So we will have 1 multiplied by y plus x multiplied by the derivative of y, which is equivalent to y prime. And then the derivative of c, which is a constant, is equivalent to 0. Now, let's change y prime into dy over dx. So we will have y plus x multiplied by our y prime, which is equivalent to dy over dx, is equal to 0. And then our next step is changing dy over dx into negative dx over dy. So we will have, uh, I'll transpose this one to the other side. So we will have y is equal to negative x multiplied by changing dy over dx into negative dx over dy. So we will have negative dx over dy, and simplifying further, we will have y y is equal to x dx over y dy. Then by cross multiplying, so we will have y dy is equal to x dx. So integrating both sides of the equation, so we will have 1 half y squared is equal to 1 half x squared plus c. So multiplying this, both sides of the equation by 2, so we will have y squared is equal to x squared plus c, or 2c. We know that 2c is also equivalent to c. So can say that is plus c. And then transposing this one to the left side, so we will have y squared minus x squared is equals to c. That's the answer. Now moving forward to our, sorry, so moving forward to our second example. So for our second example, we are given that y is equal to c raised to times x raised to 4. So first is I'll divide both sides by x to the fourth, so we can separate our arbitrary constant. So x to the fourth will cancel out on this side, on the right side. So we will have c is equal to y all over x raised to 4. Then differentiating both sides of the equation with respect to x, so we will have, as you can see, this one, we will use quotient rule. So we know that the formula for quotient rule is this. Suppose we have this, so we will have um, v du minus u dv all over v squared. So by trying the quotient rule, so we will have 0 is equal to the derivative of y, which is equivalent to y prime, multiplied by x to the fourth minus quantity, copy the first, the numerator, multiply by the derivative of the denominator, which is equivalent to 4x cubed, all over all over x raised to 4 squared, which is equivalent to x raised to 8. So by cross multiplying, we will have 0 is equal to quantity y prime multiplied by x to the fourth minus quantity y multiplied by 4x cubed. As you can see, I could transpose this term to the left side, the equation. So we will have 4x cubed y is equal to y prime multiplied by x raised to the fourth. So you can see, we could divide both sides. Uh, we could divide both sides by x cubed and x cubed. So x cubed will cancel out on the left side. So we will have this. 4y is equal to y prime multiplied by x. Now, we know that y prime is equivalent to dy over dx. And then our next step is we will change dy over dx. We will change this one. we will change dy over dx into negative dx over dy. So by this, we will have 4y is equal to negative dx over dy multiplied by x. And then, by cross multiplying, we will have 4y dy is equal to negative x dx. Then, integrating both sides of the equation, so we will have 4y squared, sorry, 4y squared over 2 is equal to negative x raised to 2 over 2 plus c. Then multiplying both sides of the equation by 2, we will have 4y squared is equal to negative x squared plus c. Then transposing this one to the left side, so we will have 4y squared plus x squared is equal to c. That's the answer. Now, let's try example number 3. So, in example number 3, we are given that e raised to x plus e raised to negative y is equal to c sub 1. So, as you can see, we could already differentiate both sides with respect to x. So, differentiating both sides with respect to x, we will have e raised to x plus e raised to negative y multiplied by negative 1 multiplied by y prime is equal to 0, because we have negative 1 here because the derivative of negative y is negative 1. And then next is I'll change y prime into, we know that y prime is equal to dy over dx. So we will have e raised to x plus e raised to negative y multiplied by negative 1 multiplied by dy over dx quantity is equal to 0. Uh, to solve our orthogonal trajectories, we should convert dy over dx into negative dx over dy. So we will have e raised to x, but first we will have plus e raised to negative y quantity negative 1 multiplied by our, we will change dy over dx by negative dx over dy, so we'll have negative dx over dy is equal to 0. So negative 1 will cancel out, so it will become positive. So we will have e raised to x plus e raised to y multiplied by dx over dy is equal to 0. And then, by, I'll transpose this one to the right side, the second term. So we will have e raised to x. By the way, this is negative y. So it's equal to negative dx all over dy uh, multiplied by e raised to negative y. And then, as you can see, I could cross multiply it. So by using cross multiplication, we will have e raised to x dy is equal to negative dx uh, e negative dx multiplied by e raised to negative y. And then it will be variable separable. So we will have dividing both sides by e to the x and then e to the x. So e to the x here on the left side will cancel out. And then I'll divide it also by e raised to negative y and e raised to negative y. So e raised to negative y will cancel out on the right side. So we will have this dy over e raised to negative y is equal to negative dx all over e raised to x. Using the rules of exponent, so we will have e raised to y dy will become positive is equal to e raised to negative x multiplied by negative dx. So integrating both sides of the equation, so we will have e raised to y is equal to the integral of negative e raised to negative x, which is also equivalent to e raised to negative x, and then our arbitrary constant plus c. So moving this one to the left side, so we will have e raised to y minus e raised to negative x is equals to c. That's the answer.